Hi guys, here we are, video 2, and we are starting on matrices, which is plural for matrix. And so what I did is sort of write some of these things already to sort of make this time a little less on here. And again, please pause the video if you're confused, rewind it. Okay, so I've spent many hours actually, oops, didn't mean to do that. Not many hours, that sounds like all I do is this, but I've taught this for a while and have tried to link this up with the movie The Matrix, which I realize may be dating me, but hopefully you all have seen it. It's a great movie. And then there were some sequels as well. Unfortunately, The Matrix in math and The Matrix the movie aren't that related, besides that they're sort of working with numbers and figuring out puzzles and things like that. So it always reminds me of this quote that's from there that says, unfortunately, no one can be told what the Matrix is. You have to see it for yourself. And so that's sort of what we're doing now, is you guys recognizing this on your own. So let's get started here. No, I don't know how to do that, so we're going to do that later. Here I give you 3 examples of matrices. And so as you can see, matrices are sort of rows and columns of numbers, and then we're going to be sort of adapting those, adding, subtracting, multiplying, solving, and things like that. So the first matrix I have here is A, and this is what's called a square matrix, because hopefully you're all guessing why that is right now, but it's mostly because there's 4 elements, 2 columns, and 2 rows. Okay, and so these numbers here, are the row. So this is row 1 and row 2. And then these ones here are the columns. So this is column 1 and column 2. Okay, and so since there's 2 columns and 2 rows, it's called a square matrix. We learned last year in geometry that squares have the same value length of their sides, and so it's the same sort of idea here. It looks like a square as opposed to these two, which look more like a rectangle. And so you name these numbers in here, 1, -1, 3, 0. These are called the elements. The elements, I think, is also something in the movie The Matrix, which is sort of an interesting parallel between the two. But elements are the numbers inside the matrix. And so in this example, A, they're 1, 3, -1, 0, B, 2, 7, -3, 0, 1.5, 19, 4/5, 3, 8, etc. The dimensions of the matrix are the rows multiplied by the columns. And you don't actually do the multiplying, it's just stating the dimensions. So, for example, rows comes first, then columns, and that's just the amount. So A here has 2 rows and 2 columns. So the dimensions of A are 2 by 2. It's a 2 by 2 matrix. And because, again, these two are the same, it's called a square matrix. Then I have this one, B. Well, let's think. How many rows, how many columns? Well, I see 1, 2, 3 rows and 1, 2, 2 columns. And so, again, rows by columns. So B is a 3 by 2 matrix. Okay, C has 3 elements, 4/5 is a fraction, fractions are okay, 3 and 8, and this I see has 1, 2, 3 3 rows, right, 1, 2, 3, and only 1 column, and so therefore, again, rows by columns, this is a 3 by 1 matrix. And so I use sort of smaller numbers here. These can go into, you know, hundreds, millions, thousands. We're not going to look at any that large, but If you ever study further in math, you will get ones like that. So, with those we can do a few different things. So, next thing I want to look at, maybe I'm not going to do that. Well, I already did it. Oh my gosh, Ms. Schulte. All right, equal matrices are essentially exactly what they say. Okay, so equal matrices are two matrices that have the exact same dimensions and elements in all corresponding positions, and therefore those elements are equal. Okay, so again, you can pause that, rewind it, but what it means is they're the same dimensions. So if I had a 2 by 2, it could only be equal to another 2 by 2. And in that case, all of the elements are equal to each other. So we're going to try an example. Okay, so solve for each variable. Okay, and I have two matrices, obviously, if they're going to be equal. W, x minus y. Oh yeah, there's variables here. Don't worry, we're going to be okay. Okay, equals 3, 5, 4, 6. So, it's saying that these two are equal. Notice they're both 2 rows, 2 columns, so this one's a 2 by 2, and so is this, 2 rows, 2 columns. If they don't have the same dimensions, they're not equal. Okay, so you couldn't do this. You could just say we can't solve in that case. Alright, so what I know is it tells me they're equal here, so everything in the same position is equal, which means W equals 3. Look at that, we already know one of these. Okay, Z equals 6. Oh my gosh, we already know 2 of them. So we still have X and Y here. These are a little trickier, but we're going to be fine. We can do this. I like the pink, I'm going to keep it. Alright, X minus Y equals 5. Well, shoot, I have 2 different variables. We just talked about this in the last video. If I have 2 different variables, I need 2 different equations. So look at that. I also have this x plus y equals 4. 2 different equations, 2 different variables. Hopefully bells are going off in your head right now like, Ms. Schulte, I know what to do. We can use elimination. Look at that. We can just add these together and the y's will cancel, right? So x plus x equals 2x. 5 plus 4 equals 9. Divide by 2. And x equals, we can make it 4.5, that's okay. And now I know x, I can plug back in to get y. Here y is positive, it doesn't matter, but since y is positive, I'm going to plug it in here. So x is 4.5 plus y equals 4. Sorry, that's a y. Subtract 4.5, and y equals 4 minus 4.5 is negative 0.5. And so, there are my answers. Answers, not answers. It's not a word. Okay? So, with that, I can also add and subtract matrices, and multiplying is actually what we're going to look at in the next video. It's a little trickier. So we're going to learn to add and subtract and solve equal matrix equations. We just looked sort of at that, but we'll look at another example. So this actually hooks up to this lovely other teacher video, but I couldn't get it to work on this tablet, and honestly, it's a little more boring than I am. So we'll just keep going here. What I can do is perform matrix addition on matrices that have the same dimensions. Again, same dimensions, okay? By adding corresponding elements, which are elements in the same position in each matrix, which is sort of what we just talked about. So, since this is 2 rows, 3 columns, I know this is a 2 by 3, 2 rows, 3 columns, so is this. Alright, great. I know I can add these. And I'm going to add and end up with another 2 by 3. because I'm not adding or getting rid of any of these values. So since they have the same, I can basically just add everything in the same position. So since in here is an addition, 1 plus 3 gives me 4. And I'm going to go along the row. Negative 2 plus 9 gives me 7. 0 plus negative 3 gives me negative 3. 3 plus negative 9 gives me negative 6. Negative 5 plus 6 gives me 1. 7 plus 12, 19. And that's my answer. It's pretty simple. Alright, so if you want more practice, try this one on your own, and then we can talk about that tomorrow in class. So this is sort of this up here is sort of an explanation of what's happening here. This right here is what's called a zero matrix, and it's just a matrix full of zeros. So this would be a 2 by 2 zero matrix. And same thing as when you're adding 0. When you add this, right, to this original matrix, add a 0 matrix, you're just going to end up with the same thing. 1, 5, 2, negative 7, because adding on 0 doesn't change anything. Alright, then they talk about the opposite up here, or the additive inverse of an m by n matrix. A is negative A. If you look at number 4 here, I have 2, 8, negative 2, negative 8, 3, 0, negative 3, 0, 0, 3, 0. And so same thing as regular addition. Hopefully you're noticing what's going to happen here. 2 plus negative 2, 0. 8 plus negative 8, 0. Negative 3 plus 3, 0. 0 plus 0, 0. So when I add on the inverse, I'll end up with a 0 matrix. Alright, so similar to subtraction, when we have subtraction here, as long as they have, again, the same dimensions, I can subtract them, and subtracting is the same as plussing the negative. So I usually think that's easier. So I have this one matrix. All right, this is a 2 by a 3. Great. We can subtract these 2 by 3. Okay, and so since I have subtraction this time, I'm going to make it addition and then distribute in the negatives. So this negative 2 becomes a positive, negative, negative. And now I can just add. So 3 plus negative 1 is 2. 2 plus negative 4, negative 2. 4 plus negative 3, 1. Negative 1 plus 2, 1. 4 plus negative 2, 2. 0 plus negative 4, negative 4. Okay? So, same thing. Try this one for extra practice, and we can talk about it tomorrow. So a matrix equation, we looked at another one on this right here, right? This was an equation with two matrices. But this one has an x value, and you want to solve for that x value, and so it works just like we've seen regular equations before. So the variable, though, x, because we're working with matrix, the variable is a matrix, so our answer is going to end up being a matrix. Okay, so same thing as in regular equations, I have x minus this matrix. To move it to the other side in order to get x by itself, I just need to add it to one side and to the other. Alright, here I have the inverse matrices because this is a negative, this is a positive, so those cancel to become a zero matrix. Now I have x equals whatever I got here. So 0 plus 1, 8 plus 3, 1 plus 1, 9 plus 2. And I end up with x. Okay? This slide talks about whether matrices are equal. Look at each pair of elements in the same position, and then they must be the same dimensions. Okay, so in A here, they're both 2 by 2, this says, and their corresponding elements are equal, therefore they're equal. So this says negative 0.75, this is negative 3/4. They don't look equal, but you know that if you evaluated this fraction, it would end up as negative 0.75. Same thing as 1/5, 1/2, and etc. Okay, number 2 is not equal. And the reason, even though my elements are equal, they don't have the same dimensions. This one is a 1, 2, 3 rows by 1 column, and this one is a 1 row by 3 columns. So this does not make them equal, and so these are not equal. Okay? In this example, they are equal. -2, -8/4. Well, this simplifies -2. 6 minus 3 is 3. 4 minus 4 is 0. 15/3 is 5. They have the same dimension, so this is yes, equal. Okay? So, pause that again if you want to look through that. Okay, one more here. I want to do one thing first. I'm going to add a 2 in here. This 2 on the outside is multiplied. So before, similar to other equations, before I do anything, I need to distribute in this 2. And I'm going to do that to every element. So I distribute in the 2 to every element. Now I have x plus -2, 4. I'm multiplying 2 times -1, -2. 2 times 2 is 4. 2 times 0 is 0. 2 times 5 is 10. Equals 10, -4, 7, -4. Okay, and so now, same thing we did on the slide 2 slides ago, except now we have an addition. Okay, same thing as regular equations, it's addition. To get it to the other side, I'm going to subtract -2, 4, 0, 10. Subtract, -2, 4, 0, 10. Okay, oh, don't worry, I'll be done by that time. So this, these are now inverse matrices, so they're going to cancel, become a 0 matrix. So x equals whatever I get here. Again, we talked about this on the last slide. Not the last slide, but a couple ago. I have the subtraction, so I'm going to just make this an addition and then change all these signs, right? Distribute in the negative, and now I can add. So 10 plus 2 gives me 12. -4 plus -4, -8. 7 plus -0. Silly Miss Schulte. There's not a 0, right? -0 can't be negative. Just 7 plus 0 is 7. -4 plus -10, -14. And there's my answer. Alright, that's it for this video. So please make sure to rewatch it, pause if you have any questions. And again, I'm going to roll this, add these up, and enter them in the quiz for this week. Have a good weekend. Bye.